So the last few parts here are looking at the total and marginal cost functions. Let's start with total cost. What the total cost is just how much you're spending to make stuff. So it's how much you spend on labour plus how much you spend on capital, if you only labour and capital. So W times your optimum L star plus R times your optimum K, or your optimum K. So we already worked out what L star and K star were in the last part. We know what W and R are, so we can write this down pretty straightforwardly as TC, total cost, is equal to twice, so 2 is W. We worked out L star to be Q over 5 to the power of 12/17 times 9 over 4 to the power of 8/17. Yeah. So that was just L star from the last part multiplied by W. And we know that R is 4, and we know what K star is from the last part. From the last part, K star was 9% Q over 5 to 12/17 times 4 over 9 to the 9/17. So these two things just come from the last part. So if we tidy that up, which we should, total cost then is equal to Q over 5 to the power of 12 over 17. A big messy term here. 2 times 9/4 to the power of 18. Sorry, to the power of 8 over 17, plus 4 times 4/9 to the power of 9 over 17. So that's your total cost. So all you do is just take your L star and your K star from the last part and just expand them out and make them as simple as you can. The reason you make them as simple as you can is because the next thing we want is marginal cost. So marginal cost is just the derivative of total cost with respect to quantity. So in other words, marginal cost is equal to DTC dQ. So we're going to differentiate this line with respect to Q. So this is total cost here. So marginal cost then is the derivative of this. So if you differentiate this, you've got a Q, the only Q left is in here. So marginal cost then is going to be equal to 12 over 17, so we're taking down this power, times 9 over 5, Q over 5. We drop in the power by 1, minus 5 over 17, times a fifth, remember this is Q over 5, times all the stuff you had before. So 2 times 9 over 4 to the power of 8/17 plus 4 times 4 over 9 to the power of 9/17. And that's your marginal cost there. Okay. So to get marginal cost, you just differentiate total cost. Might look messy, but all you're doing is just differentiate with respect to Q, and you've only got a Q in there. So then, is total cost linear? Well, it's not linear, right? You can either just look at this and say, well, we have a power of 12/17, so it's not going to, as Q goes up, TC doesn't go up linearly. Or you can remember that if a linear function is, if a function is linear, it has a constant derivative. So if this was linear, marginal cost should be constant, but it's not, it changes with Q. So total cost isn't linear. So the next thing then is marginal cost increasing or decreasing or constant? Well, the way to figure out if something is increasing or decreasing or constant is just to look at the derivative of it. So what we're going to do is we're going to look at the derivative of marginal cost. So derivative of marginal cost with respect to Q. And again, we've just got a Q in here. So we've got our 12/17 from before, and we've got a fifth from this. And then we're going to have, pulling down the power, minus 5 over 17. We're going to drop that power then by 1. So we're going to have a q to the minus 5 over 17 minus 1. Just keep it easy. We have our fifth from before times a fifth. And then this bracket just remains the same, okay? So just because I run out of word space, you've got this bracket again. So is this thing positive, negative, or constant? Positive, negative, or 0? Well, let's look at the terms. This has to be positive. This is a positive. This is a negative. This is a positive. So you've got lots of positives times a negative. So overall, derivative of marginal cost with respect to quantity has to be less than 0. Okay? So marginal cost is decreasing function in Q. As Q gets bigger, marginal cost gets smaller. So that's that question.